published in the Southeast Asian Journal. It was published by AIT in Bangkok. Koch did a lot of data, collecting data, even from West Malaya, from Chao Phraya River in Thailand, in Indonesia, even in Pakistan on the Irrawaddy River. What he found out is, if he plot the rate of sedimentation times the degree of consolidation, he found out that in some area it is still consolidating. If the sedimentation is clay, let's say in Indonesia, if sedimentation is in clay, what will happen? Let's say take the middle of this. Let's say if the rate of sedimentation in that area, in this specific area, is 10 mm per year, we found out the degree of consolidation is only 50%. Only 50%. So why is that? It has been there for thousands of years, but still consolidating. That is why in some area like in Jakarta, in Semarang, in Surabaya, in Cirebon, that area are now having land subsided. In Semarang city, for instance, the soft soil is 30 meters. Until now, it's still consolidating. In the year 1980, I went to Semarang. In Marina, in the area of Marina, it is dry. But if I go there now, that is 40 years later, now the water is about my knees. What does it mean? It means there is a land subsided by 50 centimeters. So now the land is underwater. So Semarang city having flood every day, 2 times every day. It is the flood due to the rise of the water or sea level. So every day. So that is interesting. Also Jakarta is now, where Jakarta now flooded, not like before. Now every time rain 1 or 2 days, Jakarta flooded everywhere. So don't go to Jakarta, but come to Bandung, because Bandung is high in the mountain. So come to Bandung. Now this tells you why many of the design is misinterpret the strength. So the purpose is how do we find out what is the degree of consolidation at this time? It is not because of the reclamation, no. Not only because of reclamation, it was because of the sedimentation by itself. So its own weight. So but in Jakarta, this is in Semarang, 50%. But in Jakarta, the soil is silty clay. So if we are talking about silty clay, the same amount of rate of sedimentation, we found out in Jakarta it is about 80%. So it is close to finishing, but still consolidating. So this is the problem. We are dealing with very soft soil, not soft soil, but very soft. In Jakarta, I measured in the lab, the strength is about from 10 to 20 kPa. The reality, if we do the CPT, the strength is only 6 kPa. So only half, even 1/3 of the actual strength. That is why a lot of mistake in the design. So my motivation is to help the people find out what is the degree of consolidation. Yesterday I showed you a big slide in the excavation in Surabaya. Why is that? Because of the under consolidation. Even in Jakarta, I show you, in fact, the people at UTM, they excavate only 3.5 meters. What happened? Slide, and then the slide break the foundation of the building, and the building collapsed. So as serious as that. But when they saw, we look at the data, they see it is the strength is high. In fact, in that specific failure, I found out something. What I found out is, if we check the water content is higher than the liquidity index. That is also a sign. When you see the water content is higher than the liquid limit, it means that it is still consolidating. That is also a clue. But to what degree, we don't know. Let's do it. So we have the problem with the existing compression. Now let me mention what is the theory behind that. In consolidating soil, there are still existing pore pressure. It could be due to its own weight during sedimentation. It could be because of the fill placement, like in reclamation area. It could be due to pile driving. But the pore pressure is there. The interest is, we want to know what is the existing pore pressure. Because if we bring the sample to the lab, we don't see the existing pore pressure anymore. What is the degree of consolidation to when we can expect to construct the road, for instance, to avoid damage due to consolidation? What is the current shear strength? Because I tell you, the lab doesn't tell you the truth. What is the rate of pore pressure dissipation? So all these things must be answered. So this is the illustration. If this is the soil, the soft soil, the pore pressure is there. The groundwater is here. So that difference is what we call the excess pore pressure. The concern is the excess pore pressure is there, but engineer not aware on the consequences. When he construct the sheet pile and then he did the excavation, suddenly the sheet pile collapsed. Why is that? Because they do not take into account the excess pore pressure. They do not take into account. And by mistake, they use higher shear strength. So we need to know what is the excess pore pressure. Second, the shear strength is in fact lower depending on the magnitude of excess pore pressure. Remember, the strength equal to effective stress times tangent phi prime. Effective stress means sigma minus U. Sigma is the total stress, U is the pore pressure. But we don't know the pore pressure. We always assume the pore pressure the same as hydrostatic, which is wrong. So we say because of the effective stress, which is small, so the strength is also small, because the strength is a function of effective stress. Remember, in Jakarta, Surabaya, in Java, and even in Kalimantan, the ratio of the shear strength divided by the effective stress, SU divided by sigma V prime, equal 0.22 in Jakarta. I don't know in Malaysia. In United States, SU divided sigma V prime 0.33, different number. And then Scampton in the year 1954, he said SU divided by sigma V prime equal to 0.11 plus 0.0037 plasticity index. You remember that? You must remember that. So it depends on the plasticity index. The value of the ratio of SU divided by sigma V prime, the ratio of SU divided by sigma V prime is a function of plasticity index. Anyway, in Jakarta, 0.22. So it means that if the strength is less than 0.22 of sigma V prime, it is still consolidating. Let's say your effective stress is 20 kPa, for instance. And then the strength must be 0.22 times 20, which is about 4 to 5 kPa. Is that correct? Yeah. Say sigma V prime 20 kPa. So strength must be 5 kPa. But the fact it is maybe only 1 or 2. Or let's use 100. Let's say 100 sigma V prime 100 kPa. Then your strength is 22 kPa. But actually it is only 10 kPa or 6 kPa. That's what I want to say. So you have to know what is the effective stress. So you need to know what is the existing pore pressure. In the soil sampling, excess pore pressure disappears, as I mentioned previously. Magnitude of pore pressure is not known. We don't know. And not considered in stability analysis, then it is a danger. So a lot of failure. When excavated, excess pore pressure will push the excavated face and soil collapse. So this is our concern. So I want to help the people how to find out what is the excess pore pressure. Just to let you know the development of CPT, this is, we call it the Dutch PT, the Dutch code. It was found in 1930 and then in Belgium in 1936 or 1938. This is the one that was created in Indonesia, in Bandung. So we add, this is the cone to measure the tip resistance, and that is the friction sleeve. Why did he think about it? Let me tell you the history. In fact, the history of this thing is to do the design for pile, because the tip resistance of the cone is assumed to be the same of the tip resistance of the pile. The friction, local friction, is the same as the local friction of the pile. That is the idea. Okay. Although that thing must be done correctly. Last time they used that, but it has to be corrected. But anyway, that was the first idea. So this equipment is mainly to design pile. Now in 1950, Indonesia has this. The American didn't have that. American started this one in 1970. That was done by Smartman at the University of Florida in Miami. No, Gainesville, in Gainesville. So in fact, we are 20 years away, 20 years ahead of America. In 1970, after that, in 1980, they constructed electrical cone. Indonesia still use this. So we are behind by 10 years. In 1985 or 1990, they put the cone, the electrical cone. This is the tip, this is the friction, and that is the operation element. Plus, behind is the motherboard. This is a computer. So the cost of the tip is equal to the cost of one car. So you have to be very careful when you bring this. This is one car. Okay. But it is very, very useful. I found out it is very useful. Let me tell you one thing. So we push the cone, we measure the tip resistance, we measure the friction, and we measure the operation. Now we want to make use of the operation. So the development in method of measurement, there are new sensors like operation. In fact, now they can use also to measure many things, including the contamination of groundwater. So they use to contaminate. For the big one, they can use two things. They can also measure the horizontal stress. They can also measure the shear wave velocity. So very useful. And then when they come like here, nanti Indonesia still use this. So we are behind 40 years until now. So we started to use the CPTU only in 1990. In fact, I did the first one. So because when I was in the United States, I worked with this. So why university finally allowed me to buy that one, and a lot of thesis and even project. And then only in 1 year, all the money back. All the money back. I have to tell you, the cost of the testing is about every 100 testing you get the money back. So in the year, in fact, the year 2007 or 2009, I completed 2009. We got a project, a toll road, 126 kilometers. It belonged to consortium of Malaysian and Indonesian. But to my surprise, I thought the Malaysian is ahead of Indonesia because they requested me to do the CPTU, because the CPT, mechanical CPT is no longer standard. In ASTM, no longer. What happened? So I did 100. So by doing 100 tests, in fact, our money back, the university money back. So please do that, because you will, many people will need to do that. We have development of the method of interpretation, including soil properties correlation. Development in the method of design purposes, because this one can be used directly to design foundation, to calculate the settlement directly. We no longer use C and phi. If you design and you still use C and phi, you are behind. Now we can go direct with the CPT. We can calculate the settlement. We can calculate anything. I quote this from Paul Main of Georgia Tech. In fact, he is my junior at the time, but he is more famous, of course, because he is American. If you are from Indonesia, you are talking about the Chart Beraharjo, Mr. Harjo. I have to change my name into Charleston. Then I become famous. See, the CPT sounding can be very effective in site characterization, especially site with discrete stratigraphic horizon or discontinuous lenses. This test can be done every centimeter. The reading is every centimeter. So even if you have very thin layer of lenses, 5 centimeter, it will detect. But if you use SPT, the SPT is every 1.5 meter. If you miss, also, I used the CPT to find out the sliding plane. I use SPT, it missed because it missed the sliding plane, because the sliding plane is between the two SPT location. I went to site, I checked every material, and I found that this is the sliding plane. So how do you know that? Well, it is soft. Very simple. It is soft and a lot of water. When you have sliding plane, it will have some kind of crack. Water will go through. So water go through. It will be soft and it will be a lot of water. But without that, if that has to be done by expert, because if non-expert, maybe he didn't know how to find out the sliding plane. But if you use CPT, you will find out. You will find out because in that area, your tip resistance suddenly very low. So we can use the CPT to find out the sliding plane, which is very important for the decision. Today, most of the commercial in CPT operate electronic friction cone and isocone, penetrometer, testing offline in ASTM 1995. But in 2001 also, this has been internationalized. It is a valuable method of assessing subsurface stratigraphy associated with soft material. That is the thing, organic material or even peat, potentially liquidable material, silt and sand, and also for landslide. I just quote this from Paul Main so that you don't accuse me it is from myself. No, it is from Paul Main. Because from Paul Main you must believe. From me you don't have to believe. What is the difference between mechanical CPT and CPTU? CPTU is capable of determining water pressure. CPT no. Look at this. If you push the cone, and the cone measure 10 bar. The 10 bar is coming from the soil grain resistant and the water resistant. If the 10 bar gives you 9 bar of soil resistant, 1 bar of pore pressure resistant, good, the soil is okay. But on the other hand, if you have 10 bar, the 9 bar is coming from water resistant, but the 1 bar coming from soil resistant. What happened? That is under consolidating because the pore pressure is very high there. Okay, that is make the difference. But if you use the mechanical CPT, you never know. You never know how much carried by the grain, how much carried by the water. So that is why CPTU is big different than mechanical CPT. CPTU is capable of to determine the differences whether the push is drained or partially drained or undrained. This is interesting. I show you in the dilatometer when we push, even when we push the cone in the pit, no excess pore pressure. But in clay, excess pore pressure. So we can know if there is no pore pressure, it is drained. If you push the cone in sand, no excess pore pressure. But in clay, excess pore pressure, very high. So we know if it's drained or undrained. Then we know what is the behavior of the soil. We don't need to know what is the type of soil. We need to know the behavior. This is one important thing. When I was in the United States, I learned something. Apparently, the way we name the soil is wrong. You use USCS, Unified Soil Classification System. Is it correct? No. I tell you, no. Why? If you have 70% sand mixed with 80% sand mixed with 20% clay, what do you name it? Clay sand. Okay, and then in our mind, this is sand. It has free angle, Z equal to 0. Wrong. That material, 20% clay, 80% sand, is clay. Why? No friction angle. There is cohesion. So the behavior is clay. For the engineer, it is important to have the behavior, not the type of the soil. It will endanger. No? All young people, young engineer, they don't know. When it is sand, silty sand, they put the angle and C equal to 0, but this is wrong. You did something wrong. The clay sand or even the silty sand behave undrained. When you push the cone, it has compression. It means when you put the load on top, it has compression, excess compression. Remember that. So this is very, very important thing. In our practice, in my practice, I did a lot of judgment. Sometimes people ask me, sir, what do you mean by judgment? Okay, let me tell you. I learned this from Professor Peck, in fact. Judgment is a decision based on 3 things. First, knowledge. If you don't know soil mechanics, don't try to make any judgment. If you make judgment but without understanding soil mechanics, forget it. Your judgment will be wrong. 2, experience. Like I mentioned to you, when I have clay sand, it behaves like clay. That is experience. We did the CPT and we see the compression. So it is behaving undrained. But if we say sand, it is drained. You can put, in your Plaxis, if it's drained, it will not collapse. But if you say drain, undrained, it will collapse. You can try. Any of you may use the Plaxis software or whatever, finite element software. You can put the behavior drain or undrained. Try to put undrained, it will collapse. When it is drained, it is not collapse. And then the clay sand, you put it drain, you make a big mistake, right? So we need the behavior. So 1, knowledge. 2 is the experience. 3, intuition. Intuition coming from common sense. Everybody has different level of intuition, but intuition can be trained. Intuition can be trained. Okay. If you have wife or you have husband, please tell me what your husband like. What color your husband like. If you don't know, it means that you don't have knowledge about your husband. Is that correct? If your husband like a girl, do you know? Sorry, this is joking. I'm joking. But anyway, what I want to tell you is, intuition can be trained. If you like something, you will automatically train yourself. You will always watch, if there is something like this, this is no compression. You will do the what is it? You will do the thinking willingly. So you will increase your intuition. So that 3, if you have that 3, you can do the judgment. Let's go on. CPT able to correct it effect compression at the cone area. Of course, because we have to do the correction because of the area. I will show you later. CPT capable to predict consolidation characteristic. How can? What we do is, you push the cone, and if you see the compression, stop there, and then do the dissipation test. So you wait for 2 hours, it will dissipate. If the dissipation is fast, it is high permeable. If dissipation is slow, it is high permeable. If dissipation is slow, low permeability. Fast, high permeability. So in fact, the dissipation test is the same as the consolidation test. So you see, we can have the consolidation current without doing any consolidometer test. No need. No need, you can just rely on this. In fact, this is even better. Why better? Because you push the cone, you load the soil on site. In laboratory, what happened? You restrain. The water is only moving one way, but on site it's moving three ways, three dimension. Usually the C sub V or C sub H horizontal higher than in the lab, but it is better now. CP2 is better than CP3 on predicting soil behavior. I say soil behavior and the strength parameter, of course. So there are many applications. I don't think I will show you one by one, but just mention soil profiling, complement for the drilling, determine soil parameter. You don't need laboratory test. Determine bearing capacity directly. You don't need C and phi. Estimate settlement directly without any moduli, because moduli is there. Assessment of field densification, assessment of field consolidation, evaluate liquefaction potential, provide seismic velocity, and stratification. Okay, this is how it operates. This is the one in developed in Indonesia. You push the cone.